Let us start with unit number 5, interactive applications of deep learning. As you know, nowadays, Google Assistant, self-driving cars, Alexa, Siri, it may be any kind of smartphone assistant. Everything is an example of deep learning application. We never imagine without deep learning applications in order to continue our life. These are part and parcel of our daily life. So deep learning always continues to attract us with endless possibilities such as fraud detection and pixel resolution or image restoration as well. Deep learning is ever growing industry. For example, based upon the information, we are going to produce final outcome that is in the terms of image processing. Top applications of deep learning across industries. See, self-driving cars, entertainment, virtual recognition, visual recognition, virtual assistant, fraud detection, natural language processing, news aggregation, fraud news detection, detecting development delay in children, colorization of black and white images, adding sounds to silent movies, healthcare, personalization, automatic machine translation, automatic handwriting generation, demographic and election predictions, automatic game playing, language translations, pixel restoration, photo descriptions, deep dreaming, all these applications. See, whatever the application you are seeing, this is a component that is in the terms of a Google application, Google car. It's a self-driving car. And then natural language processing. Whatever the information we have, all those components will be converted into a commonly human understandable component, what you call natural language processing. Voice assistant is similar to natural language processing. Face recognition, even though face seems to be same for two people, but the machine can recognize who is an exact person based upon some attributes, based upon some characteristics. Image restoration, and even if we have removing noisy from the images, adding sounds to images, conversion of pixels into election prediction, election voting, and election voting predictions, and then deep dreaming. It seems to be a normal image, but internally it may include in the terms of another, which is dreaming. It is a mechanism where we don't have an exact outcome. Deep dreaming. Next, playing applications and everything. And the first topic is deep learning and its role in machine vision. See, artificial intelligence is a subject where we have machine learning and then deep learning along with image processing activities, making the machine vision technology for automated visual inspection more accessible and capable. Without artificial intelligence, there is no concept of machine learning. There is no concept of deep learning. Deep learning is always trying to mimic the human brain process visual input by waveforms with the help of a highly complicated algorithms where the speed and robustness of computerized system. Robustness is nothing but a strong. This technology always provides you higher quality in the case of manufacturing industries, controlling the production cost and enhancing customer satisfaction because it is closely related with the CRM activity, customer relationship management. We have some applications such as identification and defect detection, specifically in instances where there is a highly complexity and varying image conditions. This technology is still benefit from the conventional image processing and analysis to locate the regions of interest within the image to speed up the overall process and make it more. See, identification. See, in the case of any kind of image processing, processing of an image typically by using computer is said to be image processing. Identification, image classification using deep learning categorizes image or images in the terms of similar looking objects, including those components with the subtle imperfections. Image classification can, for example, determine the lips of a glass bottle are safe or not. See this, these are two bottles. One component, one top element seems to be good. One component is going to be sharp, which is not good for drinking. Whatever the bottle it is, it may be cold drink or something. Defect detection. There is a concept what you call image segmentation. Using deep learning categorizes image neighborhoods to pinpoint the features like defects such as dents or scratches on the sheet metal. The located feature can be further analyzed and measured by using traditional machine vision tools. That means image processing is closely associated with a deep learning technology. Without image processing, these applications may not be produced. What is machine vision? Machine vision is a mechanism of a computer to see like a human being. It employs one or more video cameras, analog to digital conversion, for example. My voice produces analog signal. Analog is nothing but something is a continuous manner. If you are connected with this is called as a digital component. A digital is nothing but analog will be converted into discrete if a computer that stores the data in the terms of a digital. So machine vision is the ability of a computer to see. It employs one or more video cameras, analog to digital conversions, and digital signal processing. The resulting data goes to a computer or robot controller. Machine vision is similar in complexity to the voice recognition. Basically, machine vision, voice recognition, these applications are very difficult to handle because voice recognition may not be a single area. Different people, different pronunciations, different terminologies may produce. This technology is going to be integrated with artificial intelligence and deep learning to accelerate image processing. How does machine vision works? I told you, whatever the environment we have, an agent. Agent is a program which interact with the environment by using sensors, cameras. Once the processing over, it produces an outcome. That outcome would be in the terms of a final component, what you call it's an actuator. A robot may have a cameras, actuators, sensors, mechanisms, technology in order to produce a specific outcome. Machine vision uses cameras to capture visual information from the surrounding environment and then process these images by using a combination of hardware and software and prepares the information for the use in various applications. For this, it uses a specialized optic in order to acquire the images. This approach allows certain characteristics of image to be processed, analyzed, and measured. For example, a machine vision application as a part of manufacturing system can be used to analyze a certain characteristic of a part being manufactured and assembly line. It could determine if the part meets the product quality criteria. If not, dispose the product. So whatever the product we have, that product is exactly follows predefined criteria or not. If it follows a predefined criteria, okay, otherwise product will be removed. For this, what we require, what are the components of machine vision system? You require lighting, illuminate the scene or an object. Without lighting, it is not possible. For example, you are seeing my face. Without lighting, it displays only a darkness. Camera, which provides a lens and a sensor to capture and digitize the images. Processor consists of an industrial PC with machine vision algorithms, middleware, and artificial intelligence for analytics and processing. Output uses the data from the processor to detect robots and communicate information to other machines and software. There are lighting, camera, processor, output. So, what are the most widely used systems that excel in pattern recognition tasks? First one, 3D vision system, that is multiple dimensions, 3D images. Smart camera based vision systems, compact vision systems, PC based vision systems, multispectral imaging, hyperspectral images, variable magnification lenses. How are machine vision systems are utilized? Machine vision applications are used in a range of industries in order to perform the various tasks. Some of those tasks may be electronic component analysis. For example, you are going to perform some construction of circuit boards, such as shoulder plates, inspection, and component replacement or replacement. Optical character recognition, what you call OCR. It is related with the optical, whatever the human handwriting, maybe handwriting text from the images. Handwriting and signature recognition, object recognition, pattern recognition, material inspection, currency inspection, item counting, barcode tracking, robotics, etc. What are the benefits of machine vision? Machine vision always produces lower cost because no human involvement is associated. Whenever the human involvement is associated, ultimately cost will be increased. Removes human error. Whenever there is a presence of human, automatically it leads to some kind of error. There is no human error at all, which removes human error. Whenever there is there exists a human element, there is a possibility of downtime, what you call a failure time. But in the case of machine system, machine vision is concerned, reduces downtime, improves workplace safety, identification of a flash, it measures accurately, identifies the printing defects as well. So, machine vision, machine, this is artificial intelligence, image recognition, machine learning, deep learning, natural language processing. Now start with the next concept, natural language processing. Natural language processing is an approach we are going to give to the computers with the ability of understanding the text and the spoken words in the same manner as a human can understand. NLP, natural language processing, refers to a branch of computer science and more specifically, a branch of artificial intelligence concerned with giving the computers with the ability to understand text and spoken words in much the same way a human being can understand. So, NLP is a mechanism of building the machine that can manipulate the human language or the data that look like resembles human languages in a way that is written, spoken, organized. We are going to build a technology in order to accomplish our useful task. NLP technologies enable the computer to process human language in the form of a text or a voice data and to understand its full meaning, complete with the speaker or read his intent and sentiment too. That means, in general, a machine may not have the ability to understand the spoken words that are defined by the user. But NLP, in the case of deep learning technique, natural language processing is the ability in which a machine can understand whatever the words that are spoken by the human being. NLP can be divided into two overlapping subfields. Number one is NLU, natural language understanding, natural language generation. Natural language understanding is nothing but a semantic analysis or determine the intended meaning of text. Whereas natural language generation, which focuses on text generation by a machine. Text generation by a machine is NLG. Natural language understanding is NLU. It is often used in combination with, in conjunction with speech recognition, which seeks to parse. Parsing is nothing but dividing the spoken language into the words and turning the sound into the text and vice versa. Natural language tasks. Generally, human language may not be unambiguous. It includes ambiguities. Ambiguity is nothing but confusion. There are, say, various categories of idioms, metaphors, grammars, homophones, harmony, anything, but it may be vary from part to part in the country or country to country. Language differs in the case of a area to area and the person to person. And voice modulations may also be separate. So human language is filled with some kind of ambiguities. Ambiguity is nothing but confusion that make it incredibly difficult to write software that accurately determines the intended meaning of text or voice data. So several NLP tasks break down the human text and voice data in a ways that help the computer make sense of what it is ingesting. Some of the tasks includes speech recognition, say this, automatic speech recognition. Here, there is a natural language processing, which means that speech to text is a task of reliably converting the voice data into text data. In many applications are also there. There is a Google Translate is also there. Part of speech tagging is also called as grammatical tagging. It is a process of determining the part of speech of a particular word or a piece of text based on its usage and the context. Say this, where I like to read books. Word sense disambiguation. It is a selection of meaning of a word with multiple meanings through a process of semantic analysis that determine a word that makes the most sense in a given context. For example, if you specify a specific word, we are going to verify that particular word is exactly linked with, connected with that particular sentence or not. Named entity recognition, NEM, identify the words or the phrases as useful entities. Sentiment analysis, attempt to extract the subjective quantities, attitude, emotions, or confusions, or any other kind of components from the text. Natural language generation, it is opposite to a speech recognition or speech to text. It's a task of putting structured. See, there are two words. One is structured, second one is unstructured. Structured is nothing but everything is organized. Unstructured is nothing but everything is unorganized. So NLP, already I told you, is the use of human languages by a computer. So natural language processing includes various applications such as machine translation, and it also defines probability distribution as well. Natural language processing can process sequence of words rather than a sequence of individual characters or bytes. Several strategies have been developed to make the models of such a space efficient, both the computational and in a statistical sense. Next one is n-grams. A language model defines a probability distribution over the sequence of tokens in the natural language. I told you a spoken token is nothing but a small word, a small character, or even a byte. Tokens are always discrete entities called different entities. Earlier successful language models were based on models of fixed length sequence of tokens called n-grams. An n-gram is a sequence of n kind of tokens. Model based on n-grams define the conditional probability of nth token given the preceding n minus 1 token. It uses a formula that is p of x1 to xt. and p of x1 to xn minus 1, pi of t is equal to n to t, p of xt such that xt minus n plus 1 to xt minus 1. So in the same way, we are going to find the computational activity for n minus 1 component. Neural language models, NLM. These are the class of language models designed to overcome the curse of dimensionality problem for modeling natural language sequences by using a distributed representation of words. Unlike class-based n-gram model, instead of n number of tokens, n-grams, neural language models are able to recognize that two words are similar without losing the ability to encode each word as a distinct from other. Neural language models share statistical strength between one word and other similar words under context. For this, we have an example. If the word dog and the word cat map to the representation that shares many attributes, then sentences that contain the word cat can inform the predictions that will be made by the model of further sentences that contains the word dog and vice versa. But the basic idea of using distributed representation is to improve the model for language processing, and it is not restricted to neural networks as well. So NLP, natural language processing. And then next concept is generative adversarial networks. GAN, important topic. See, two neural networks are compete with each other. Competition is nothing but competition by using deep learning methods to become more accurate in their predictions. See, we have a raw data, collecting the data, organizing the data, processing of data, and storing and producing the predictions. Predictions always not correct, but whatever the information we are going to produce more accurate predictions. So a GAN is a machine learning model in which two neural networks compete with each other by using deep learning methods to become more accurate in their predictions. The goal of a generative adversarial network is to generate new syntactic data. What is syntactic? See, whatever the content that is in brackets given under red color line is a definition for that. That is only for your understanding. I think there is no need to write the same in bracket. There is no need to write in examinations. Syntactic data is information that is artificially manufactured rather than generated by a real-world event that resembles some known data distribution. What is generative adversarial networks? Generative adversarial networks are a powerful class of neural network that are used for unsupervised learning. As you know, there are 4 categories of machine learning algorithms we already seen in the case of unit number 1. It is a supervised, unsupervised, semi-supervised, and reinforcement algorithms. These are basically made up of system of 2 competing neural network models which compete with each other and are able to analyze, capture, and copy the variations with the data set. The data set is nothing but whatever the data that is provided. It has been noticed most of the mainstream neural networks can be easily fooled into misclassifying things by adding only a small amount of noisy into the original data. What is noisy? Unnecessary part of data, unused component of data. If the model after adding the noisy has higher confidence in the wrong prediction than when predicted correctly. So that's why we require it. It leads to misclassification of data. GANs can be broken down into 3 parts, that is generative, adversarial networks. In this model, it describes how the data is generated in the terms of probabilistic model. And then the training of a model is done in an adversarial settings. Use deep learning network, deep neural network as an artificial intelligence algorithms for training purpose. See, whatever the information we have, training data, whatever the data that is in the terms of experiences, in GAN, there is a generator and a discriminator. Generator generate fake samples of data and tries to fool the discriminator. See, generator always trying to create fake samples of data. It may be audio, video, or images or anything. Whereas we are going to make the discriminator to fool. But the discriminator try to distinguish between the real data and fake samples. For example, if you are going to produce any kind of predictions, we are not supposed to select only a original data along with the fake data need to be assembled together so that we can distinguish which one is a fake data, which one is a real data. Generator and the discriminator are both neural networks and they both run in competition with each other in training phase. The steps are repeated several times, and in this, generator, discriminator get better and better in their respective jobs after each repetition. Work can be visualized by a diagram. We see this. This is a generator, and here random variables, latent random variables. See, which produces fake samples. Fake samples are fed to the discriminator. Here we have a real data samples. Samples generated, fake samples by the generator. And discriminator checks, is it correct? No. Automatically fine-tune training. That means it always trying to produce only the real components. Even though generated produces fake samples, those fake samples are going to be identified and removed. In a more clear form, there is n-dimensional vector, generator network, fake images, discriminator network, and real images that is going to be compared, and it produces proper labels. Here, the generative model captures the distribution of data and is trained in such a manner that it tries to maximize the probability of discriminator making a mistake. On the other hand, discriminator is based on a model that estimates the probability that sample that it got is received from the training data and not from the generator. So what is our target? Generator produces both fake and real. Discriminator is going to identify exact samples, that is the terms of real, so that we can produce proper and perfect predictions. Gen ANs are formulated as minimax game, where the discriminator is trying to minimize its reward, V of D comma G, and the generator is trying to minimize the discriminator reward, or in other words, maximize its loss. The same thing can be written in the terms of a formula: generator, discriminator, distribution of real data, distribution of generator, sample from P data, sample from P of Z, discriminator network, and generator network, minimax function. Different types of generative adversarial network models: vanilla GAN, conditional GAN, deep convolution GAN, Laplacian pyramid GAN, super resolution GAN, SRGAN. Advantages. See, generative adversarial networks can produce synthetic data generation that resembles some known data distribution, which can be useful for data augmentation. Anomaly detect. Anomaly is nothing but a problem. High quality result, it always produces high quality outcome. It may be video synthesis, image synthesis, music synthesis on the task. Unsupervised learning, without having a proper labeled data, it can produce unsupervised learning. Versatility, various categories of elements, wide range of tasks can be executed by this application. Next one, disadvantages. Automatically, it produces both the original data, fake data for generator, discriminator, and combining of machine learning in order to compete with each other to produce more accurate predictions. Automatically, it produces computational cost, overfitting. See, I told you in previous sessions, there are three kinds: overfitting, underfitting, exact fitting. Training, instability, computational cost, overfitting, bias and fairness, interpretability and accountability. That means everything need to be strong, everything accountable, transparency, and fairness in their applications. Training, instability, computational cost, overfitting, biasing and fairness, interpretability, and accountability. These are the elements associated with the advantages and disadvantages of GAN, generative adversarial networks.